Hey guys, today I'm going to do a short tutorial on how to use Starling and Nape using Actionscript free. Now, what Starling is a framework for Flash that allows GPU rendering of display objects or graphics. Now, this means you can have blazingly fast performance on any device, and it's great for mobile devices. Now, normally Flash will render using the CPU, which is very intensive, and that's why Flash usually runs slow. But Starling enables you to access the graphics pipeline and harnesses the power of the Flash's Stage 3D. And the Stage 3D technology is fairly recent. It was brought around in 2012, I believe, maybe 2011. But I will leave a link in the description of where you can read a bit more about Stage 3D. But anyway, I'll move on to Nape. Nape is a physics engine written by a guy called Luca, I believe, and it's a alternative to Box2D for Flash. And the reason it's mainly used in Starling is because one, it's compatible with Starling, and two, it's actually, turns out it's about 5 to 6 times faster than Box2D in most of the operations, and it contains a lot of features that Box2D doesn't actually contain. So I recommend that you do actually use Nape because it's a fantastic alternative to Box2D. So to get started, I'm going to tell you where you can download the source files for Nape and Starling. And what we're going to do is we're going to download the SWIC files. And SWIC files are basically ActionScript libraries that you can import into your projects and use them as you would normal ActionScript code. Now, as you can see here, we've got 4 different SWIC files. But I'm going to tell you where you can download these first. So you can navigate to your browser, and you're going to go to gamua.com/Starling, and this will bring you to this page here. And this website has a lot of useful information for Starling, and it has quite a few examples if you go to the forum. And Starling is a great framework. So if you want to download it, click the download button on this page, and then we want to download the SWIC file. So we will click download here, and we'll wait for it to download. Now, after you've finished downloading, if you open up this the zip file, you will find a SWIC file. And what you would want to do is you want to extract that to your project directory and place it within the source files or your own folder. Now, to download Nape, what you need to do is you need to go to the Nape website, which is napephysics.com, well, napephyz.com, and you want to navigate to the download section, scroll down a little bit, and it's a little bit different to Starling because it has 3 different SWIC files that are actually core to the actual Nape itself. And you will be wanting to get the dev one for this tutorial, but you could just as easily use Nape Release or Nape Debug. For this one, I'm going to be using the development one because if you read a little bit up here, it says it's to be used during the development because it contains extra logic to check if you are using the Nape API correctly. And this means it's better because it'll tell you if you're doing anything wrong. So, now you've downloaded them both, you'll just open up the folders, and in the Starling one it'll look a bit dodgy at first. Just ignore all of this, go to Starling, and inside bin there will be a starling.swic. That's the one you want to extract. So extract that to your project and all will be fine. And once you've downloaded this SWIC, this will just download the actual SWIC file itself. So you'll get the SWIC file there, and then you drag that into your project. Now to import it, you may be using a different IDE to me. I'm using Flash Builder, but in most IDEs it's the same. If you want to learn more, you can Google or search on your search engine, favorite search engine, how to import SWIC files. So in Flash Builder, I'm going to go to Project Properties, and then in here you will see an empty library like this. And what I'm going to do is I'm going to add a SWIC file, and I'm going to browse for it. And the first one I'm going to add, pardon me, is the Starling SWIC, and I'm going to press OK, and this will import the Starling SWIC. And I'm going to add the second one, which will be my Nape SWIC, and I'm going to be using the dev build of Nape, and that's it. That's all the work you need to be done complete. So now let's get started with the code. I have my main document class, which is main. As you can see, it says my document class here, says default application, and inside this we have a Starling instance, and that's of the type Starling, which is the Starling main class. It's the class that basically will control Starling itself. And in this function I'm going to set the frame rate to 60, and we're going to make a new Starling instance, and with this we pass in 2 parameters. You can optionally pass in many more parameters which it asks for, but for now we're going to use 2 because that's all we really need to pass through. We're going to use a stage, which is our current stage, and we're going to use physics world. Now, as you can see, there's no mention of a item called physics world on this actual class. You might be a little confused, and the physics world class is actually here. Now, as you can see, it's a whole different class that contains everything that we're actually going to do. And this parameter actually tells Starling the class you want to run as soon as Starling is initialized, or as soon as Starling starts. Now, the reason you need to pass this in is because Starling has its own sprites. I'm not going to go too much into it, but you need to pass this in as soon as you create a new Starling instance, and as soon as Starling starts, as soon as you run that start function of Starling, whatever's in this class here will start to run, and this class must extend sprite, and this isn't going to extend the flash display sprite. This is actually going to extend the Starling version of sprite. And how you get a Starling sprite is, instead of up here, instead of importing the flash.display.sprite, this would cause an error. So you'd want to import the Starling.display.sprite here. And Starling actually names a lot of things the same as Flash does, and this is fairly annoying when you get overlaps or within the same namespace. But basically, we're just going to ignore that for now, and we're going to move on. Just remember that you want to pass in the first class here as soon as you initialize Starling, and then you need to run Starling instance.start. Don't forget that, that's really important. I always forget it, and it always never gives me an error, and I never understand what's going wrong. But yeah, you have to call that. Okay, so in this class here, we're going to have 4 different variables, and we're going to have my debugger, which is a type of bitmap debug, which will allow us to show all the objects in the physics world which are present, and it will draw it for us. We're going to have my space, which is of type space, and this is going to be the actual physics world. It's going to be the world within which Nape works with, and we're going to have screen width and screen height. Now, in the main function, we're going to add an event listener for Starling event. As you can see, the event here is actually a Starling event, so make sure you import that instead of flash.events.event. And to make sure you do this, when you're actually typing event, you can see here that it will offer 2 suggestions. It will offer either Starling.events or flash.events. So you choose Starling events, and this won't cause an error. And then we're going to run the onInit function as soon as that is dispatched. So as soon as everything's working, as soon as Starling has recognized you, as soon as Starling runs this class, and as soon as this sprite has been added to the stage, we will do this. Now this is where we get into the real code, where we actually create the demo that we're going to do. And we have 2 functions here, and we have an event listener. The 2 functions, we're going to first initialize the debug and the Nape world, which is called space, and then we're going to initialize the bodies, and a body is basically an object that exists within the physical space of Nape. That can be a constraint, it can be a joint, it can be basically anything that exists in the Nape space is a body. Anything like a physical object. A joint and a constraint aren't really bodies, they're just, I don't know how to explain it, but yeah, a body is just a physical object that exists within Nape. And then we're gonna, after we've done that, we're gonna add an event listener, and we're gonna add a Starling event, obviously Starling events.event, And Starling also has a event.enterFrame, and then we're going to call the update world function every frame, which will be every 60th of a second. Now, on the init debug space function, we will have a variable called world gravity, and that will be of type vec2. Now, vec2 is a Nape variable type, or a Nape type. And as you can see, if I try using vec2, it'll say it's in the nape.geon package, and then we set this equal to vec2.weak. And then inside this, you pass in two parameters, which is the x and the y values, because a vector has a x and a y. A two-dimensional vector will have an x and a y property. X is horizontally and y is vertical. And obviously, we're going to set, if it's gravity, we're not going to have any horizontal movement, but if it's vertical and it's gravity, then we are going to have a vertical movement. And we're going to have a positive vertical movement because gravity is going downwards, and on the screen 500 is also downwards, so it's going to be positive. And a value of 500 might seem a bit random, and to be honest it kind of is in my own eyes, but it seems to give me fairly reliable results, and it works pretty fine with me. It gives a fairly realistic physics gravity for me. And then we're going to initialize the variable MySpace with a new space, and then we pass in the gravity, because that's what it actually expects. It expects us to pass in a gravity, which is a vector2. And we're going to ignore the broad face. Screen width will be set to Starling. Make sure this is the original Starling, as in it's not an instance of Starling, it's the class Starling. .current .native stage .full screen width, and this will return the actual full screen width of the stage. So this is only for mobile. If you wanted to return the screen width on a computer, you'd take away the full screen, as you can see there. Oh no, it'll be stage. So if you wanted to just do this for a computer, for example, you'd set these variables to that. But if you want to do it for mobile, I recommend doing full screen width and full screen height. Then after this, we'll make the debugger, and it will be equal to a new bitmap debug, and the parameters it's expecting is a width and height and a color. And as you can see, we're going to pass in the screen width and the screen height, and we're going to pass in the color black. So it's a nice black background, and it's going to be the size of the actual screen width and screen height. And this will show us on the screen, it will show us all the objects within the space that we're going to work with, because when you draw the debugger, it asks for a parameter, and we'll pass in a space, so it'll draw everything in that space. Then we call the add child function from the stage, or the native overlay of Starling. Starling has a property called native overlay, and what this is it's an overlay on top of the stage 3D that you can add items to, and the debugger for Nape, isn't compatible with Starling GPU, so it will be rendered normally, and this is very slow for mobile devices. So if you're developing for a mobile device, I don't recommend you use the debugger. I recommend you take off the debugger and you replace all the graphics with actual graphics, which I'll teach you in the next tutorial or a few tutorials down the line. But I don't really recommend using this debugger for a mobile project. So that's how you add it. You add it to the native overlay, because it's not actually a Starling display object, it's a native flash display object, as you can see, and the native overlay expects a flash object to be passed in, a flash display object, and that's what my debugger.display is. Okay, so the second function we run is Initialized Bodies, or init bodies. It might look a bit complicated here, but basically we're going to create a floor, and there's going to be a body, and as I explained before, a body is something that exists within the physical Nape space, or the Nape world, physics world, and we're going to set the floor type to bodyType.static. And bodyType is a class in Nape which contains a few different properties: dynamic, kinematic, and static. Dynamic means it will be affected by gravity, it will be affected by other objects, etc., etc. So we don't want the floor to be that. We want the floor to be static, as it won't actually be affected by any gravity, but dynamic objects will still be affected by this static object. And then we're going to run floor.shapes. This is all the shapes that the floor will contain, such as maybe we want a polygon shape, or maybe we want a circle or a rectangle or a box, etc. So we're going to add a... Now this code is confusing. I wouldn't blame you if you found this a bit confusing. So we're going to add a new polygon. As you can see, a polygon is also a Nape class. And inside here, it expects an local verts, which is the local vertices of the polygon. And to get the local vertices without having to do a complex sort of object structure, you can just simply call polygon.rect. Or you can do a box or a regular, but we want a rectangle one. And in here you set the X position of that rectangle, then you set the Y position, then you set the width, then you set the height. So here we want a rectangle for the floor that starts at 0 on the X-axis, and then it starts at the bottom of the screen minus 20 pixels, and it will be the width of the screen, and it will be 20 pixels tall. So it will act as an actual floor. And then what you want to do, if you want the floor to be in our space, which we do, we have to set the space property of floor to the current space we're working in. Now, in our example, as you can see, there's a floor at the bottom, there is a boulder here, and there are many little square objects. And this is how we make the boulder. We do variable boulder, and it's a body, which is again a physical object, and it's of body type .dynamic. And as you can see up here, I set the floor.type outside of the parentheses, but in here you can actually set it inside the parentheses if you want. When you're making a new body, you can set the type inside the parentheses. Now, the boulder, we're going to have a shape inside the boulder, and it's going to be a new circle, which is a Nape property again, and inside here it's expecting a radius, so we're going to have a radius of 50, which means it'll have like a width of about 100. Okay, so, and then after this, we're going to set the shape materials of the boulder. And now this is a good function in Nape because it's quite easy to make your own materials. Like you can make a very elastic sort of ball, you can make a very strong ball, and what we're doing is we're making a very strong one. The boulder is going to be very strong, it's not going to be affected much by other objects around it, it's just going to bash through them, as you can see in the example. And the way we did this is I simply called material.steel, which is a property that's already preset and it gives you a really strong material. But if we wanted to make our own material that was very elastic, we would simply call new material, and let's say we wanted a really bouncy ball that wasn't really affecting the objects around it, we'd just set the very elastic. And as you can see in this example, it kind of just bounces rather than goes through them all. And there we go. So I'm going to reset this to material.steel. And then we do boulder.position.setXY, and now this allows us to set the boulder's position easily with one line of code. And we want to place the boulder at the top of the screen in the middle. So we're going to call screen width divided by 2 for the X position along the horizontal axis, and then we're going to set 100 for the Y position so it's visible on the screen from the start. And then we want to set the boulder space to the current space we're working in, which is my space. Now this is going to look a bit confusing, but it's not, it's just my very messy way of kind of placing all those squares that you see in the middle of the screen. And I called them bricks because the boulder kind of bashes through the bricks, and that's the way I worked through it. But we're going to call brick, and it's a new body, and it's body type .dynamic. And we're going to add a new shape. It's going to be a new polygon. It's going to be a box of width. Instead of a rectangle, it's going to be a box, and a box differs from a rectangle because it only has a width and height property, and it will be placed where you set the brick's position. It's going to be 20 width and 20 height. That's why you see many boxes on the screen. We do 2 for loops. The top for loop is for the vertical, so each time this loop runs, it will run 10 of these loops, and for each one of these loop runs, it will place a break on the horizontal axis. So it'll place 10 bricks horizontally, then it'll move up one here, then it'll move 10 bricks again horizontally, then it'll move down here, then it'll move 10 more down, 10 more down, and it'll keep on doing that recursively until it finishes. And this will place 100 bricks in a nice 10 by 10 stack. And basically we set the XY position to screen width. We basically center all these blocks so it looks nice in the center. And you might as well just copy that code down if you wanted to make an example, but you get the idea. We're setting the position. And then we set the space to my space again. And that means all the bricks, the boulder, and the floor will all be in our local space, my space. So they'll all interact with each other in this world. Now in update world, it's very simple to do this. We call my debugger.clear, and this clears the current picture that's on the debugger. And now Nape uses a unique sort of method for updating its own world, and there's a function inside of the space called step. And what this does is it kind of advances in time the space, so like the time kind of actually exists. And what this parameter is it's how much you want to advance it by in the second. So if I did 1, it would advance once a second, and if I did over 60, it would advance 60 times a second, which is our frame per second. So basically what you really want to do when you're updating the world is do 1 divided by whatever your frames per second is. In our case we said 60 before. And then after we've done this, we want to draw the debugger, and we, as I told you before, we'll pass in my space, and this means it'll draw all the objects on the space. And then we do the flush, which actually pushes it to the screen. It flushes it and it kind of makes sure everything gets displayed correctly. Now that's basically the example explained. There's not much more I'm going to go through in this tutorial, to be honest, because I think I've covered everything on basic level. There's not anything I really want to mention extra in this tutorial. I don't think that I want to set anything, but for example, what we could do is we can just simply set a brick material, set shape materials, and then we'll make a new material. And if you want to mess around, you can just set some of these values yourself. Like I'll set that to 2, I'll set that to 1, I'll set that to 2, and I'll set this to like 0.5. And as you can see, I'll just be messing around with these values. And if you mess around with these values enough, it'll significantly change your actual output results. And as you can see, everything's all bouncy and sort of messy. And it's fun to mess around. Oh, and another quick thing to mention is Nape is very good in terms of performance due to the fact that, as you can see here, all these objects are they've faded out. And the reason for this is because when Nape isn't actually using an object, it'll put it to sleep, which saves performance. So if you have many objects that are sleeping, then your performance will be very high, and it does it very efficiently. And when objects need waking up again, they will automatically wake up. Nape does that for you, and the Box2D API does not actually provide that, I don't believe. So that's another reason to use Nape. So that concludes this tutorial, and I hope this helps you. And tomorrow I will probably be uploading another video on how to like make a rope sort of system or something in Box2D. So keep tuned for that, and I hope I helped you learn something this time. Please suggest what I can do to improve, and I'll kind of take into note what you say and I'll improve. So yeah, thanks for listening, guys. Hope you have a great day. Thanks. Bye.